Welcome uh, to the Maths Champions Arena. This is your own channel. This is Maths Champions Arena. I feel those who are viewing this video is a champion. Okay. Today the date is 8. That means 2025 November, and I'm going to solve today two problems, two sums in the class. See, I don't want to mention it as a problem, but let us maintain it as a sum. So, what is the sum one? Or if you ask me, sir, what is the topic? So, I say it is indefinite integrals. Indefinite integrals. Or integration. I say integration. So, what is the problem number one, which I'm going to address now? Is that, problem number one should be uh, when we say integration. Number one, what happens to in every student condition is that by looking at the integral sum itself, or we see example problems itself, we get little troubled or trembled, right? So first of all, let us understand differentiation. What is the difference between differentiation? There is something called differentiation. The opposite of it, the opposite of it, the opposite of it is integration. So the problem one, what would I say? Differentiation. So d by dx of, suppose, say, differentiation. If I write a variable x, simply x, it is nothing but x. What will be differentiation of x? It will be nothing but n into x power n minus 1. But what is 1? X, simply we say variable, the power is 1. So answer of d by dx of x power 1 would be 1 into x power 1 minus 1. So this will become 1 into x power 0. From the principles of exponent and powers, this x power 0 is nothing but 1. So answer would be 1. Next, moving on to the other end of this particular sum, I have integration of x now. Integration of x dx. If I say this, what will happen here? The answer would be x power n plus 1 by n plus 1 plus c. This should be my answer in the integration part. So if I say integration of x simply x, the variable here is x power 1, which is n. So this is the answer would be x power 1 plus 1 by 1 plus 1. That is plus c. Which is something x square by 2 plus c. So now moving on to the second problem, or if I say problem number 2, yeah. So if I say sum 2, now let us come to the sum 2 part, which I call it as, this is something called sum 2, and that too in integration itself. So I have dy dx of now 1. What does d by dx of 1 gives me? That means differentiation. What does integration of 1 dx gives me? These two are the problems I have to address now. So here I have differentiation of 1, and here I have integration of 1. You remember 1 is nothing but a constant. This 1, whatever 1 we are writing, This is nothing but a constant. So how do I write this differentiation of 1? I write this as x power 0. So by the formula n into x power n minus 1, n into x power n minus 1, I write it as 0 into x power 0 minus 1. Of course, 0 into anything comes to be 0. So the answer here is 0. So you remember just the answer here is 0. Now if I go to the next part, that means integration part, here I convert this 1 to be as x power 0 dx. By our notation scheme, we write this as answer as n plus 1 by n plus 1 plus integration constant. So this comes to be x power 0 plus 1 by 0 plus 1 plus c. What is 0 plus 1? 1, and x power 1 is x. So answer would be x plus c. So integration of 1, differentiation of 1 is 0, but integration of 1 is dx. Now you should be in a position to observe some things. That means very important observation here. Very important observation is that if I say d by dx of x, it is 1. Now if I say integration of 1 dx, it is x. See this phenomena you can easily observe what is happening here. So this particular differentiation of x is equal to 1, when it is coming to this place, what is happening? Integration of 1 dx is becoming x. Okay, we'll again look into the next video with another two problems. Bye.